Alright, so in this problem, I have 4 to the power of x is equal to 12. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 12. Now if I have something in the form log a to the power of b, this is equal to b times log a, because all I have to do is simply move my exponent to the front. So for log 4 to the power of x, I can move x to the front. So this is going to equal x times log 4 is equal to log 12. Now we obviously want to isolate x here, so to do that I have to get rid of this log 4 by dividing on both sides. So then these two cancel out, and now I have x is equal to log 12 over log 4. Now, log 12, that's equal to log 4 times 3. Now I have this over log 4. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 4 times 3, that's going to equal log 4 plus log 3 over log 4. And this is equal to log 4 over log 4 plus log 3 over log 4. Now log 4 and log 4, these two cancel out, so now I have 1 plus log 3 over log 4. Now log 4, that's equal to 2 squared, so I have x is equal to 1 plus log 3 over log 2 squared. And log 2 squared, that's the same thing as 2 times log 2. Now log 3 is equal to 0.4771. And log 2, this is equal to 0.301. So now I have x is equal to 1 plus 0.4771 over 2 times 0.301. And this is equal to 1 plus 0.7925, which is equal to 1.7925. Alright, so in this problem, I have 4 to the power of x plus 16 to the power of x is equal to 64 to the power of x. Now, 16 I can rewrite as 4 squared. So now I have 4 to the power of x plus 4 squared to the power of x. And now 64 I can rewrite as 4 to the power of 3. Now I'm going to rewrite this as 4 to the power of x squared. 4 to the power of x plus 4 to the power of x squared is equal to 4 to the power of x to the power of 3, because I can switch the places of these two. Now I'm going to let 4 to the power of x equal to the variable u. So now I have u plus u squared is equal to u to the power of 3. Now to solve this, I'm going to start by factoring out, I'm going to start by subtracting u squared and u on both sides. So then these two cancel out, and now I have u to the power of 3 minus u squared minus u is equal to 0. Now I can factor out u, so I have u times u squared minus u minus 1 is equal to 0. Now to solve this, I can divide this into two parts. U equals 0, and u squared minus u minus 1 is equal to 0. So u equals 0, this is already a solution. And to solve u squared minus u minus 1 equals 0, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm not going to waste your time actually plugging in everything into the quadratic formula, but you should end up getting u equals 1 plus the square root of 5 over 2. And u is equal to 1 minus the square root of 5 over 2. So now, remember how we set 4 to the power of x equal to u. So first, I have 4 to the power of x equals 0, and there's no solution to this because you can't take the power of a number and make it equal to 0. So now I have 4 to the power of x is equal to 1 plus the square root of 5 over 2, and 4 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it negative, so this is no solution as well. So I have left with 4 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So now I have x times log 4 is equal to log of 1 plus the square root of 5 over 2. Now if I divide both sides by log 4, these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 4. Alright, so in this problem, I have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of x plus 8, that's going to equal 7 to the power of x times 7 to the power of 8. And a to the power of x plus 7, that's going to equal a to the power of x times a to the power of 7. Now I'm going to divide both sides by 7 to the power of 8 times a to the power of x. So then these two cancel out and these two cancel out, and I'm left with 7 to the power of x over a to the power of x is equal to a to the power of 7 over 7 to the power of 8. Now this is the same thing as 7 over 8 to the power of x is equal to a to the power of 7 over 7 to the power of 8. And now I'm going to take the log on both sides. So now I have log 7 over 8 to the power of x is equal to log of 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So log of 7 over 8 to the power of x, I can move x to the power of front. So now I have x times log 7 over 8 is equal to log of 8 to the power of 7 over 7 to the power of 8. Now log of a over b, this is equal to log a minus log b. So log of 7 over 8, that's going to equal log of 7 minus log 8, which is equal to log of 8 to the power of 7 minus log of 7 to the power of 8. Now if I divide both sides by log 7 minus log 8, these two cancel out, and now I have x is equal to 7 times log 8, because remember I can move the exponent to the front of both of these, minus 8 times log 7 over log 7 minus log 8. And from here, if you plug in all the values of log 8 and log 7 into the equation, you get x is equal to negative 0.4399. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 times 3 to the power of 33. So to solve this, I'm going to first rewrite 2 to the power of 22 as 2 to the power of 2 times 11. and I have this times 3 to the power of 3 times 11. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this turns into 2 to the power of 2 to the power of 11 times 3 to the power of 3 to the power of 11. Now 2 to the power of 2 is 4, so I get 4 to the power of 11 times 3 to the power of 3 is 27, so 27 to the power of 11. And now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this turns into 4 times 27 to the power of 11, which is equal to 108 to the power of 11. So this is my answer.